as people have been kind of brainstorming, let's run down this quickly and make sure we're okay with the approach. PR, that's this segment right here, that's 12 units. So how long is TR? 6. Because the rule is, if it's perpendicular, I know it bisects. Because there's the radius. Now I've got SQ as 14, but that's not what I'm looking for. I'm looking for just that little part below it. So that means what I need to do is say, all right, I do have this triangle I can solve. That's 14. That's 6. That's a right angle. I want x. So I can get that using the Pythagorean theorem. I said it once, I've said it at least, I don't know, twice now. Almost this entire chapter is Pythagorean theorem problems. They're all triangles. So now I can go ahead and apply that. I'm looking at 14 squared is equal to x squared plus 6 squared. So 14 squared is 196. 6 squared is 36. Subtracted, I have 160 is equal to x squared. Now, because I'm going to be doing more operations, I'm not going to get tied up on simplified radical form for this, because it'll just get too crazy later, and I'm going to have to turn it into a decimal approximate. I don't have the option of staying in radical form for this problem, unfortunately. So 160 square root is 12.65. 12.65. If you're going to round to, you should always do it to 2 decimal places unless you have really big numbers. 4 significant figures is pretty much all you need. And that means now I can figure out what that length is. The radius is 14. I can subtract 12.65. And that leaves my answer of 1.35 for TQ. That little leftover piece at the bottom. This top piece right here, that's the 12.65. That little piece must be 1.35 in order to make a circle out, in order to make the full 14 of the radius. Can we start knocking these out?